Hello students, welcome to the next module. Today we are going to understand a few numericals based upon the series combination of resistors. Remember, we had done initially the derivation when three resistors of resistances R1, R2 and R3 are connected in series, then their equivalent resistance is R1 plus R2 plus R3. Right? Now, if I have three particular resistors, say 6 ohms, 5 ohms and 4 ohms. They are connected in series. Can you guess now what will be their equivalent resistance? It will be the sum of all the three resistances, which is 6 plus 5 plus 4, and that is 15 ohms. Right? So as we can see that the equivalent resistance is far more greater than each of the individual resistances. So when we require greater resistance, we make use of a series combination of resistors. Right? With this, we move on to page number 213, blue box question. Right? Beginning with the first blue box question. Draw schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each. So we have a battery 2 volt each consisting of 3 cells, right? Then we have a 5 ohm resistor. We have a 5 ohm resistor, one 8 ohm resistor and one 12 ohm resistor and a plug key, all connected in series. So we have to draw a schematic diagram of the same. Remember, we start with the battery first. Battery is the combination of cells. We do it in this manner. So this is 2 volt and 2 volts. So this becomes total 6 volt, right? So it's a combination here. Next, we have 3 resistors in series, 1, 2 and 3. And their equivalent and their resistance is 5, 8 and 12 ohm respectively. We have a plug key over here. Right? So this is the very first part of this question where we have drawn a schematic diagram. Right? We have to, in the second part, this is first. The second part of the blue box question, the second question, redraw the circuit of question 1, putting in an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across 12 ohm resistors. So we do the first part of question number 2, that is, we make a schematic diagram again and we have to put an ammeter here. So we have a 5 ohm, 8 ohm and 12 ohm resistor. Initially, when we were discussing about the roles of ammeter and voltmeter, I told you that ammeter is always connected in series with the circuit and voltmeter is always connected in parallel. So it has been asked that put an ammeter to measure the current through the resistor. So we will put an ammeter over here. Let the battery be here. This is a plug key, right? And we need to add a voltmeter across a 12 ohm resistor. So a voltmeter across a 12 ohm resistor. So here is V, right? This will be positive, negative. This will be positive, negative. This will be positive and negative. Current I will be flowing here. Since we are talking about a series combination of resistors, right? Here the potential difference is 6 volt. What would be the readings in the ammeter? We should know that the ammeter measures the current. So how much current will be flowing? Remember, current through the entire circuit will be the same through 5 ohm, 8 ohm and 12 ohm resistor. So first of all, we will be making use of the Ohm's law over here. Ohm's law states that V is equal to IR. What are we supposed to find out? We are supposed to find out the ammeter reading. Means current we are supposed to find out is equal to V upon R. And what is R? R here will be the equivalent resistance in series. So we have to calculate RS, which is 5 plus 8 plus 12. And how much is that? That is 25 ohms. So what is I in this case? I is V, which is 6 volt upon 25, right? And what is 6 upon 25? Well, how much? We can calculate this. So we have the answer as 6 upon 25 amperes, right? Now we can convert it into decimals, right? So this comes out to be 25 and this is 6. 25 twos are, so that's 50. Then we have, so it's 0.24 ampere as the ammeter reading. Remember, here the units are very, very important to mention, right? Because that will tell you what are you actually measuring. What is an ammeter actually measuring? It is measuring current in amperes. Now we have to calculate the voltmeter reading. Voltmeter reading. Remember, this current I which we have calculated will be flowing through 5 ohm resistor, 8 ohm resistor and 12 ohm resistor. In series combination, what varies? The potential difference varies, right? So we have to calculate. Again, we'll be using the Ohm's law, that is V is equal to IR. Since I have to calculate the value of V, I is how much? 0.24 and the resistance is 12, right? Because 0.24 current will be flowing through 12 ohm resistor. So we can calculate this as, so we have 24 divided by 100 into 12. So that's 144 divided by 50, or we can say 2.8 volt, right? So that will be the reading. I hope it's clear, students. Let me check this. 5 2s are 2.88 volts, right? Next, we move on to the parallel combination of resistors. So we'll talk about the parallel combination of resistors next. In case of parallel combination of resistors, please remember one thing, that we need to be very careful with the combination of resistances that we make use of. So here we'll be drawing a circuit diagram first of all. So the circuit diagram for the combination of resistors R1, R2 and R3 which are connected in parallel. We have 3 resistors, each of resistance R1, R2 and R3. This is R1, this is R2 and we have this as R3, right? So they are connected with a battery. We have an ammeter over here. So this is parallel combination of resistors. So this circuit diagram I'll just explain. There are 3 resistors of resistances R1, R2 and R3 respectively, connected to a battery whose potential difference is V, a plug key ammeter. In this case, what will change here, we will see that it is just the inverse of a series combination. Here I changes, but potential difference V remains constant. So if current I is flowing here, at this particular point, it will get divided into I1, I2 and I3. Remember, the potential difference across the 3 resistors remains the same. And as the potential difference across the 3 resistors, across the 3 appliances remains the same, we make use of the parallel combination of resistors or parallel combination in household circuits. Why? Why that is so? Because the potential drop across all the circuits is the same. That's the reason why we make use of the parallel combination of resistors. So quickly we will do this. We have I is equal to I1 plus I2 plus I3, because I is the total current and it is divided into I1, I2 and I3. So that is I1 plus I2 plus I3. Remember, V is equal to IR according to Ohm's law, or I is equal to V upon R. So instead of I can write V upon R. I1 is equal to, V is the same. What is different? The resistance. So here I can use V upon R1. This is V upon R2 and this is V upon R3 instead of I3, right? V upon R can be written this way. I can take V as common. So I have 1 upon R1 plus 1 upon R2 plus 1 upon R3, right? This V and this V we can cancel because they are common on both the sides. So I have 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And this R is the equivalent resistance in parallel. So let us say we have 2, 3 and 4 ohm resistors in parallel. We have to calculate their equivalent resistance. So we calculate it this way. 1 upon Rp is equal to 1 upon 2 plus 1 upon 3 plus 1 upon 4. So what is its LCM? 2, 3 and 4. So 2 1s are 3, 2 2s are 2, 1, 3 and 1. And here we have 3, 1, 1 and 1. So that's 3 2s are 6 2s are 12 is the LCM. 2 goes into 12 how many times? 6 times. 3 goes into 12 4 times. And 4 goes into 12 3 times. So that is 13. 6 plus 4 10 plus 3 13 upon 12. So this is equal to 1 upon Rp. But what do we need to calculate? We need to calculate just Rp. So Rp is equal to 12 upon 13 ohms, which can be further converted into decimal. So this is how we need to calculate the equivalent resistance in parallel. I hope it is clear to you, students. In the next class, we will discuss the blue box questions based upon the parallel combination of resistors. Till then, please go through all the topics thoroughly. Thank you.